Life on Earth. What is life? It's not too difficult to tell that some things are alive. Dogs chasing tennis balls are alive. Birds chattering in a hawthorn tree are alive. Minnows swimming around the plants in a pond are alive. In fact, animals are the first things we learn to recognize as living. Things that are alive, like the animals described above, are called organisms. An organism is an individual living thing, such as a plant, animal, fungus, bacterium, or protist. Any living thing is an organism, but not all organisms are animals. Plants are organisms too. In the scenes above, the berry tree is alive, and the water plants in the pond are alive. It's not always so easy to tell that plants are alive because they don't do some of the things we usually think about when we think about life. Plants don't move around, breathe, eat, or make sounds. Even so, they are alive, and there are ways to figure out that they are alive. Living, dead, and non-living. One way to look at the question, what is life, is to think about what makes life come to an end. Every living organism dies after a period of time. An organism is dead when it is no longer alive. A fish out of water will die after a short period of time. The fish is still there. It is still made out of the same materials, and it still looks the same as it did when it was living in the water. But it's no longer alive, and this is important. Something can only be dead if it was once lived. A rock can never be dead because a rock was never alive. We describe the rock as non-living. Living organisms can be described in terms of two sets of characteristics. One is the needs or requirements that all organisms have to satisfy to stay alive. The second is the function that all organisms do. What do living organisms need? What do you need to stay alive? It has been said that a person can live 5 minutes without air, 3 days without water, and 5 weeks without food. People need air, water, and food to stay alive. You breathe air to stay alive. When you breathe in, you bring oxygen into your lungs, where it dissolves into your blood. When you breathe out, carbon dioxide, carbon monoxide, and other waste gases leave your body and go into the air. The process of moving gases into and out of your body is gas exchange. Gas exchange is one of the characteristics of all organisms. Gas exchange occurs at the cellular level with carbon dioxide, oxygen, and water vapor being the most common gases exchanged. Birds do it, bees do it, lizards, fish, baboons, stink bugs, and trees do it. All living organisms engage in gas exchange, and the most common gases involved are oxygen and carbon dioxide. You drink water to stay alive. Even if you don't actually drink pure water, there is water in the fruit, vegetables, soft drinks, milk, and everything else you eat and drink. Water is essential for life as we know it on Earth. It's just that simple. All living organisms need water. You eat food to stay alive. Food contains energy. Energy is required to make things happen. You can't move, breathe, see, hear, think, or do anything else without energy. All living organisms use energy to live. Using energy is the capacity to do work. Most of the energy used by living organisms comes from the sun.
Lunch is the best time of day, right? Well, sometimes anyway. But even if lunch turns out to be nasty, like a banana and ketchup sandwich, if we're really hungry, we'll eat it. That's because we're living things, and all living things need to eat, or really need to eat to get energy in order to survive. But tigers and humans are both living things, and you don't tend to see tigers hanging out at the salad bar. So what's the deal? How do different types of living things get energy? Well, everything starts with the sun. We may slather on the sunblock and pull out the shades when things get too bright, but plants don't. Instead, they do something only a few kinds of living things can do. They catch energy that comes from the sun's rays, and they change it into chemical energy, specifically a kind of sugar. Then other living things, like humans, eat the plants and use that sugar as energy in their own bodies. It's like swallowing sunshine, but much tastier. And more filling. Scientists classify or group animals based on how they get energy. Some living things get energy by eating mostly plants or parts of plants like fruits or seeds. These animals, like deer and cows, are called herbivores, even though they eat all kinds of plants, not just the herbs that go in pizza sauce. But if you're looking for an animal to split a burger or carne asada taco with, you'll want to call tigers, hawks, or other carnivores, animals that eat mostly meat. While humans, bears, raccoons, and other animals whose diets include both plants and animals are called omnivores. Now, you can come up with a really simple model to see how these groups of living things fit together based on how they get energy. Say we're out for a walk. There's sun shining on an apple tree, a raccoon hiding in the tree's branches, some insects munching on the tree's leaves, and a hawk circling over a field nearby. How can you arrange these things in a way that shows how they get energy? Well, first we know that the apple tree doesn't really eat anything. It's a plant, so it can take the sun's energy shining on its leaves, plus some air and water, and make sugar. So what about the animals in this scene? Since the insects are making a salad out of the tree's leaves, it's safe to guess that they're herbivores, plant eaters. The raccoon would be happy eating either the apples from the tree or the insects, since it eats both plants and other animals. It's the omnivore in this situation. If the raccoon leaves the safety of the tree, it might get picked off by that hawk, a meat-loving carnivore. So as you can see, all living things get energy that starts off with the sun. Plants take this energy and change it into chemical energy. Some animals, herbivores, get their energy by eating mostly plants, while others, the carnivores, get it by eating mostly meat. And omnivores, like humans, get their energy by eating both plants and animals. Now if you'll excuse me, it's time for this omnivore's lunch.
The process of living produces byproducts that are of no use to organisms. In fact, many byproducts are dangerous to the organism if they are allowed to build up. For this reason, it is necessary for organisms to get rid of waste products. These might be gases, liquids, or solids. All living organisms eliminate waste. Solids, liquids, or gases that are unusable by the cells of organisms and must be moved outside the cell. These four basic needs are common to all living organisms: the need for gas exchange, the need for water, the need for energy, and the need to eliminate waste. What do living organisms do? Once an organism's basic needs are met, it gets on with the process of life. One of the universal truths is that everything has to be somewhere. That somewhere for an organism is its environment. People live in towns and go to stores and schools, ride in vehicles, shop, read, watch TV, eat, and millions of other things. The human environment can be colorful and complex. Fish live in oceanic environments. Scorpions live in desert environments. Maple trees live in forest environments, and so on. When things happen in the environment, organisms respond. All organisms respond to the environment. Responding to the environment means all organisms are influenced by their environments. The things organisms do when they are influenced by the environment are called responses. The ocean fish swims away when the sea lion comes by. The scorpion scurries under a rock when the sun heats up the ground. And the maple tree's leaves turn red and fall off in the autumn. These are all responses to the environment. When organisms start life, they are small. As time passes, they get bigger. Increase in size is called growth. The chemical building blocks for growth come from food and from the environment in the form of minerals. All organisms grow. Growing is the increase in size of an organism. Growth is characteristic of life. Organisms don't live forever. Some live a short time and some live a long time, but eventually every individual will die. To make sure that the species doesn't become extinct, living organisms make new organisms of their kind. Even though the ways that different kinds of organisms do it vary dramatically, all living organisms reproduce. Reproducing is the process by which organisms create new individuals of their kind. Some reproduce asexually, without the joining of two cells, and others reproduce sexually, the joining of egg and sperm cells. All organisms do three things. They respond to the environment, they grow, and they reproduce. Anything that does not have the ability to do all three of these things is not an organism. There is actually one more characteristic common to all living organisms. That characteristic is not discussed in this article, but will be introduced in the near future. Can you think what that characteristic might be? It's true of you. It's true of turtles and beetles. It's true of elm trees and mosses, and of all the tiny living organisms too small to see with the naked eye. Sometimes it is difficult to decide if something is alive. A car driving down the road exchanges gases, and a washing machine needs water. A burning candle uses energy, and a fire gives off waste. A smoke alarm responds to the environment. Clouds grow, and the mint reproduces new dollar bills all the time. One characteristic, or even 3 or 4, does not qualify an object to join the ranks of the living. In order to qualify as a living organism, an object must pass all 7 tests. is an organism? What are the basic needs of all living organisms? I'll read it again. What are the basic needs of all living organisms? Number 3. What functions are performed by all living organisms? What functions are performed by all living organisms? And number 4. What is the difference between living, non-living, and dead? One more time. What is the difference between living, non-living, and dead?